when the potentially hazardous asteroid 9942 Apophis makes its breathtakingly close flyby of Earth on April 13, 2029. More than 2 billion people across Africa and Western Europe will be able to watch it drift across the night sky. Under clear skies, the space rock will appear as a faint star, about as bright as the stars in the Big Dipper and easily visible to the unaided eye, gliding steadily overhead. Pause for a few seconds and support me with a subscribe. Apophis flyby will mark the first time in space history that a potentially hazardous asteroid is visible to the naked eye. Richard Benzel, a professor of planetary sciences at MIT, said Monday, Sept. 8, during a keynote address at the Europlanet Science Congress in Helsinki, Finland. Astronomers estimate that a close approach by an asteroid this large, 1,100 feet, 340 meters across, or roughly the height of the Eiffel Tower, occurs only once every 7,500 years. For the public, it will be a dazzling once-in-a-lifetime spectacle. For scientists, it promises something even rarer, a once-in-a-millennium natural experiment to watch in real time. How Earth's gravity reshapes a massive asteroid. We don't know, Benzel said, and we won't know until we look. Benzel, a pioneer in asteroid hazard research and the inventor of the Torino impact hazard scale that's used to rate impact risks of asteroids and comets, underscored one point above all. If you take nothing else away from this talk, I want you to take away 3 things, he said. During his presentation, Apophis will safely pass the Earth. Apophis will safely pass the Earth. Apophis will safely pass the Earth. When Apophis was first discovered in 2004, however, the picture was far less certain. Early calculations suggested a 2.7% chance of impact on April 13, 2029, placing it at level 4 on the Torino scale, the highest rating ever given to a near-Earth object. Scientists named the asteroid 99,942 Apophis after the Egyptian god of the underworld, earning it the nickname the God of Chaos asteroid. Over the next 2 decades, continuous tracking and radar observations narrowed Apophis' orbit from hundreds of miles of uncertainty to just a few. By 2021, Apophis was formally removed from all risk lists, and scientists estimated it posed no threat for at least the next 100 years. In September last year, however, a study noted there is still a tiny possibility that an unknown asteroid could nudge it onto a collision path before it's close. Earth flyby in 2029. The odds are over 1 in a billion, and while scientists won't be able to fully rule out this scenario for another 3 years, astronomers remain confident Apophis poses no danger for the next century. It's been a lot of work by a lot of people to make sure we can say totally and confidently that Apophis will safely pass the Earth. Absolutely no doubt, Benzel said. While Earth itself will barely notice the encounter, Apophis will not leave unchanged. As it passes just over 18,600 miles, 30,000 kilometers, above the planet's surface, closer than geostationary satellites, its Aten-class orbit, which lies mostly inside Earth's path around the Sun and is thus often hidden in our star's bright glare, will be reshaped into a wider Apollo-class trajectory. Its rotation may also shift, which might send the asteroid into a fresh tumbling state, Benzel said. The Earth won't care, but Apophis will care, because Apophis' orbit will change, he said. It's all about the encounter physics. To capture those changes firsthand, NASA has reassigned its OSIRIS-REx spacecraft, fresh from its mission to the asteroid Bennu, to a new role as OSIRIS-APEX. The probe will rendezvous with Apophis before the flyby, mapping its surface, monitoring its spin, and measuring how Earth's gravity alters the asteroid during its close pass. Among the most tantalizing goals, Benzel said, is the chance to measure seismic vibrations inside Apophis. In 60 years of planetary science, we've only measured seismicity for 2 objects, the Moon and Mars, he said. This would be the opportunity for another leap forward in seismic measurements. and interpretation of interior properties. That leap could come from the Rapid Apophis mission for space safety, RAMSES. The European Space Agency, ESA mission, if approved at ESA's Ministerial Council in November, would launch in spring 2028 and arrive at the asteroid by February 2029. The mission's goal would be to observe Apophis before, during and after its flyby of Earth. Monica Lazzarin, a professor of physics and astronomy at the University of Padua in Italy, and a member of the RAMSES science team, said at the conference, hovering as close as 3 miles 5 kilometers from the asteroid during its April 12 to 14, 2029 encounter, RAMSES would map Apophis orbit, search for dust clouds raised by tidal forces, and possibly deploy a small satellite called a CubeSat to touch the surface and detect seismic waves, Lazzarin said. Beyond science, Apophis is a proving ground for planetary defense, scientists say, as it will aid humanity's effort to understand and prepare for the rare but real risk of an asteroid impact. While Apophis itself poses no danger, it belongs to the class of near-Earth asteroids that could one day threaten our planet. By studying how Earth's tidal forces reshape Apophis, scientists can refine the models that would be critical for deflecting the hazardous asteroid. Apophis is not a planetary defense emergency, Tom Statler, a planetary scientist at NASA headquarters in Washington, D.C., added during a Q&A session at the conference. It is an opportunity, and an unprecedented one. Asteroids are not something to be scared of, he added. There's something to understand, and that's what we're doing. Let's pause for a few seconds and give me a like for this video. Thank you so much. When a massive asteroid is hurtling toward Earth, the solution seems straightforward. Smash a spacecraft into it and knock it off course. That's exactly what NASA successfully did with the DART mission in 2022. They proved this concept works and dramatically altered the orbit of the asteroid Dimorphos. But new research reveals the chilling possibility that an asteroid hit in the wrong spot, and you might just be postponing the impact. Scientists at the University of Illinois have discovered that poorly aimed asteroid deflection attempts could accidentally steer space rocks through dangerous regions in space known as gravitational keyholes. That would, alas, still mean they hit Earth just years or decades later. A gravitational keyhole is a small region of space where a planet's gravity can modify a passing asteroid's orbit, such that it returns on a collision course with that planet at a later date. Think of it like a rather funky pinball machine where hitting the wrong bumper sends the ball ricocheting back toward the flippers. Even if we intentionally push an asteroid away from Earth with a space mission, we must make sure it doesn't drift into one of these keyholes afterwards. Otherwise, we'd be facing the same impact threat again down the line. Rahil Makadia from NASA. To solve this problem, Makadia's team has developed probability maps that identify the safest spots to strike each asteroid. Each point on the surface of an asteroid has a different probability of sending the asteroid through a gravitational keyhole after deflection by a kinetic impactor. Creating these maps requires detailed knowledge of the asteroid's characteristics, such as its shape, surface features, rotation, and mass. Ideally, this would be done with a space mission to rendezvous with the asteroid, producing high-resolution images and data. However, if an asteroid is discovered late with little time before impact, scientists can create preliminary lower-quality maps using ground-based telescope observations alone. The researchers have already created probability maps for well-studied asteroids like Bennu, complete with crosshairs marking the optimal impact zones. These maps account for the inevitable uncertainties in any space mission, since even the most precisely aimed spacecraft might miss its target by several meters. While DART's target, Dimorphos, was chosen precisely because the Didymos system is too massive to be deflected onto a collision course with Earth, future asteroid threats won't be so forgiving. Real planetary defense missions will require a high level of precision planning. The European Space Agency's HERA mission, set to reach the DART impact site in December 2026, will provide valuable data to refine these techniques. We have been really quite lucky so far. Nothing significant has been found to be heading straight for us, but as we continue exploring the sky, eventually, one day, we will spot an asteroid with Earth's name on it. Thanks to Makadia and his team, when we do need to play planetary defense for real, we'll know exactly where to aim. Hopefully. Experiments on Earth indicate some common species of bacteria and fungi could survive for several days on the Moon's surface, suggesting missions must take stronger precautions to avoid contamination. The Moon might be more hospitable to life than we thought, increasing the risk of future Moon missions contaminating the lifeless lunar surface. Space missions must follow policies on planetary protection to avoid contaminating other bodies of the solar system with microbes from Earth, which might mislead us into thinking these bodies have their own life forms. Many of the protections we have on Earth, such as our atmosphere and magnetic field, don't exist on the Moon. As a result, its surface is exposed to high-energy particles from outer space, extreme temperatures and lethal ultraviolet light from the sun, making it a harsh environment for organisms to survive in. Because of this, most astronomers consider the lunar surface essentially sterile. The Committee on Space Research places it in the second lowest category of planetary protection, along with Venus and comets, for bodies that have only a remote chance that spacecraft-borne contamination could compromise investigations. But new research by Stefano Bertoni at NASA Goddard Space Flight Center and his colleagues suggests life might be able to survive for days or potentially more than a week in some regions around the Moon's poles, which is where NASA's future Artemis mission is planning to visit. This means there is a risk missions will contaminate these areas, leading to false positives in studies searching for life. We are going back to the Moon. We will leave traces. We need more work to understand what kind of traces we will leave and how to minimize them, Bertoni told the Europlanet Science Congress, EPSC, in Helsinki, Finland, on the 12th of September. Bertoni and his team looked at 5 common organisms that are naturally resistant to extreme environments, including black mold, Aspergillus niger, and the bacteria Staphylococcus aureus and Bacillus subtilis, and tested how much ultraviolet light they could withstand in the laboratory. Then they compiled data for UV levels, sun exposure, and temperature fluctuations on the Moon's surface and used this to produce a map showing where the 5 organisms could survive for at least a day. All the organisms could survive in areas that are well lit, outside of the permanently shadowed regions where the sun and UV light can't reach, said Bertone. And these well-lit areas are potential targets for lunar exploration. Black mold was the hardiest, surviving in large regions for up to 7 days. It's a very important study, and it's clear that if there is a danger of contamination, then certain actions should be taken, but also it should be understood that such actions will have economic consequences, says St. Barabash at the Swedish Institute of Space Physics. For example, space agencies may decide equipment has to be sterilized more rigorously, and this will affect the cost of missions, he says.